This set of notes introduces precipitation reactions and solubility rules. All right, so before stoichiometry, we talked about three patterns of reactivity: synthesis, decomposition, and combustion. Precipitation reactions are another pattern of chemical reaction known as the double replacement reaction. Okay, and so precipitation reactions are a kind of double replacement reaction where you start out with two aqueous products, okay, or reactants, sorry. Both are soluble. So in an example down here, we've got potassium iodide, we've got potassium nitrate, lead nitrate, aqueous. Both of them are aqueous, meaning that they're both soluble in water and they're both dissolved, okay? In the process of going through this double replacement reaction, what happens is the ions will swap spots, okay? And when they do that, one of them is insoluble, okay? So it will drop out, and that is known as our precipitate. Okay? In this particular reaction, the precipitate that drops out is lead iodide, okay? The other two ions typically stay still dissolved in solution. In this case, it would be the potassium ions and the nitrate ions, okay, that we got going on over here. So in this particular case, we again end up with one aqueous product that stays dissolved and one insoluble product. And again, that is known as our precipitate. This particular reaction is shown up here. I'll probably show it to you in class too as well. But here are soluble potassium iodide and soluble lead nitrate. They're all dissolved in the two different beakers. When you put them together, the lead iodide ions and the iodide ions will connect together to form particles, larger particles, that will then drop out of the solution. Okay, those particles that drop out of the solution are the precipitate. They're insoluble, and the other things remain dissolved in the water. Okay, it is the formation of this precipitate that is the thing that drives this reaction to actually be able to go. Okay, so in the previous reaction, we had said that lead iodide was the precipitate. And so the question is, how do we know which substance is going to be the one that is going to stay dissolved, and which one is the one that is going to precipitate out? Well, the answer to that lies in some, again, patterns of predictability known as solubility rules. Let's listen to them.
Solubility rules, they're really great. They help predict precipitation. What a marvelous tool. Solubility rules. Alkali metal ions are really swell. Assume their compounds are always soluble. Those ions are hardly precipitators. In reactions, they're usually spectators. And that positive one ion NH4, its compounds are soluble for sure. And that negative one ion NO3, nitrates are as soluble as can be. Solubility rules, they're really great. They help predict precipitates. What a marvelous tool. Solubility rules. Of course we know one thing is always true. There are always exceptions to the rules. Sulfates are soluble, it's said, except with barium, strontium, and lead, and a few others. Chlorides, bromides, and iodides are soluble. But there are some secrets, well, I'm gonna tell. Working in the lab, it's plain to see. They're insoluble with silver, lead, and mercury. Solubility rules, they're really great. They help predict precipitates. What a marvelous tool. Solubility rules. except when paired with ammonium or alkali metal ions. Hey, it's hard to make this simple, but I'm trying. So consider all the possibilities and use the rules to guess the solubilities. The most important thing that you must keep straight: the insoluble combinations precipitate. Solubility rules, they're really great. They help predict precipitates. What a marvelous tool. Solubility rules. Solubility rules, they're really great. They help predict precipitates. What a marvelous tool. Solubility rules. Solubility rules. Solubility rules.
Okay, so as you can see, there's tons and tons of different solubility rules that would help you out. Beautiful thing about AP Chemistry is they're not going to actually require you to memorize all of those solubility rules. Hey, that's great. Most of the time, if you need to know the solubility of something, you would be given a solubility table. However, there are a few exceptions to that. Right? In AP Chemistry, you are expected to know that any salt, just simply meaning ionic compound, that has a group 1 metal in it. So any of the alkali metals. Okay, so any ionic compound with the alkali metal in it is soluble. You're also expected to know that anything that has ammonium, NH4 in it. Okay, so again, group 1 would be Na, Li, K, lithium, potassium, rubidium, cesium, francium. Okay, there we go. Ammonium salts, anything with NH4 in it is soluble. That's NH4 plus ion, and anything that has a nitrate ion in it, NO3 minus ions, are soluble. Okay, if you know those groups, every question on the AP exam would assume that you know that those things are soluble. So therefore, anything else they would present you with would either be insoluble or they would give you other information. What other information might they give you? They might give you a solubility product constant, which we'll learn about in a few units. Or they just assume that you know these are soluble, so the others are not insoluble. All right? So that's the big rules that you need to know. So all the ones in the song, don't worry about them. Just know that. Alkali metals, ionic compounds, ammonium ionic compounds, and nitrate ionic compounds are soluble.